Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. These are the GATE 2021 Mechanical Engineering toppers from Exergic. You can find their preparation strategy on Exergic's website. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. Now, whenever we do something in our day-to-day life and we do it again and again and again, then a time comes when we stop thinking about why we are doing it. We don't think about the reason of doing something from the zero level every time, right? It becomes a habit and we just do it without thinking much. I'm sure you can think of many such examples in your life where every time you are not thinking everything from the zero level, but just it becomes a habit and you start doing it, right? Now this is something which can be a good thing if the habit is good, but when it comes to solving questions, it is definitely not a good thing. Which means that whenever you are solving a question, whenever you are reading a question, you always have to respect that question. You always have to read that question in such a way that think from the basic concepts every time, right? Don't just go for applying the formula, don't just go for applying whatever habits you have formed. And this important learning we are going to get from the question that we are about to solve. As well as this question will talk about a special case in heat transfer in unsteady conduction. So I want you to pay attention till the end in the question that we are about to solve. The question says that a person pours milk into a thin walled glass of 6 centimeter opening. So there is a glass in which a person is filling milk, and it's a thin walled glass, okay, of 6 centimeter opening. So the glass has an opening of 6 centimeter. So basically this is nothing but the mouth of the glass is of 6 centimeter, you can say, or the diameter of the glass is of 6 centimeter. Now the milk is filled up to 7 centimeter in the glass. So obviously it's filling the milk, and up to 7 centimeter it has filled the milk in the glass. He then places the glass into a large pan filled with hot water at 60 degree. So the glass he was having, he puts that, right? He places that glass into a large pan filled with hot water, into a very large pan which was filled with hot water at 60 degree, okay? And then milk is stirred constantly, right? So if you have this milk in this glass, then using a stirrer, using a spoon, using anything, that is being stirred, mixed constantly, right? And as a result of that constant mixing, what happens? So that its temperature stays uniform at all times. So its temperature stays uniform. If the heat transfer coefficient between the water and the glass is 120 watt per meter square degree Celsius, so it is placed in a large tub which has water, hot water, and this is milk. So it is saying that heat transfer coefficient between water and glass is given as 120 watt per meter square degree Celsius, and take thermal conductivity of the glass as 0.1 watt per meter Kelvin. Neglecting thermal resistance of the glass wall, this glass of milk that has some thickness, that is going to offer some resistance, but neglecting that, the time it will take for the milk to warm up from 3 degrees Celsius to 38 degrees Celsius is how many minutes? So initially the milk might be cold, and slowly its temperature is going to rise. How? Because it is placed in a hot water tub, and heat is going to flow into the milk, increasing its temperature. Definitely it's not a case of steady state conduction. It's unsteady state conduction question that we are dealing with, and it is asking you how much time it will take in minutes to increase its temperature from 3 to 38 degrees Celsius. Milk properties has been given, thermal conductivity has been given, density has been given, specific heat has been given, right? So in this question, before starting to discuss it, let us focus on the important keywords of the question. I have highlighted those keywords. Firstly, this glass is thin walled, its walls are very thin, right? So it's not going to play much role in the material of the glass is not going to play much role in the heat transfer, and that's what this is also saying, neglecting thermal resistance of the glass wall. Even if this was not written, still we would have neglected, or the answer that we will get by neglecting the thermal resistance of the glass wall would have been very close to the answer if you consider the thermal resistance. Why? Because initially it has said that it is thin walled glass, right? So its effect on the whole process is going to be negligible, but anyway, question has clearly mentioned it, so making the question slightly easier for us. So there is just milk and then water. The thickness we are not going to consider, its thermal resistance we are not going to consider. Now, since it is placed, the glass of milk is placed in a large pan filled with hot water. What does that mean? What is this trying to say? What is the significance of large pan? Why not small pan? Or why not simply pan? What is the meaning of writing large here? Meaning of writing large here is that the larger tub into which it is placed, that has a lot of water. So water itself is not going to decrease, the temperature of water itself is not going to decrease. That's like a thermal energy reservoir for this small glass of milk. So water is going to supply the heat at a constant temperature of 60 degrees Celsius, which it is at initially. So that temperature we can consider as T infinity in this calculation, right? Like the ambient temperature, like the reservoir temperature, that's the significance of this large here. And now coming to one of the most important part of this question, which is milk is stirred constantly so that its temperature is uniform at all times. What is the significance of that? Look, whenever we are going to solve such question of heat transfer, obviously we look at the problem and we see that whether it's a question of steady state heat transfer or unsteady state heat transfer or unsteady state conduction, right? On the basis of that, we decide which approach we are going to take. This is clearly a question of unsteady conduction. And what is the first thing that we do if we get a case of unsteady conduction like this? We try to apply the lumped analysis, and for that we try to calculate the Biot number, correct or not? Because calculating Biot number, a value less than 0.1 tells us that we can apply lumped analysis. Then we go for the expression and we do the calculation. Now think once from the basics. In the concept of lumped analysis, what is the basic funda of lumped analysis? That if Biot number is less than 0.1, which means that temperature gradient within the body are negligible. The temperature variation within the body are small. Hence, from the point of view of thermal analysis, it can be considered as a lump, as a single body, as a single unit. That is the basic concept on which we do the lumped analysis, right or not? If the Biot number is high, which means that temperature variation is going to exist beyond permissible limit in the milk in this given case, because it is going to receive heat from the external environment. So this milk near the surface is going to get heated up quickly. That temperature will raise faster, but slowly heat will reach at the center and increase the temperature. So if you compare the temperature within the milk near the center, near the core and near the surface, clearly there is going to be a temperature gradient, temperature differential, and then Biot number will be the judge. That will decide, Biot number will decide whether this is permissible or not, whether we can consider this as a lump or not, and we can apply lumped analysis or not, correct? In this case, I am not going to do that. And why I am not going to do that and why it can give you an incorrect answer? That you will understand by the end of this discussion. Now let us try to calculate the Biot number, right? The usual step that we start with in any question of unsteady heat conduction, we start with calculating Biot number to see whether we can apply the lumped analysis or not, right? In this case, also we are going to proceed with the same method, same step. And to calculate Biot number, we need to find out the characteristic length, which is V divided by A, volume by area. Here it's a glass of milk, volume is pi r square L, suppose L is the total length of this, divide by total area, which is the curved surface area, 2 pi r L, plus the area at top plus at bottom. So curved surface area plus 2 times of the cross sectional area, pi r square, right? You can now simplify it, you can cancel the pi, you can cancel some values of r, then you can put the values. Ultimately you are going to get this characteristic length, 0.0105 meter, right? Obviously you need to convert into appropriate units, you need to take care of diameter and radius. Question gave you the diameter, right? 6 centimeter opening, 6 centimeter diameter. Here it is radius. So accordingly you need to put 3 centimeter, convert to meter, and then you will get this characteristic length. Now the interesting part starts from here. If you put the value of characteristic length 0.0105 here, H value is also known to you. H value is given 120, right? And for milk, K is also given to you, correct? Don't do the mistake, don't put this value of K, right? This is the thermal conductivity of the glass material, which essentially we have to ignore. So don't put this value. This is the value of K that we will have to put for milk, correct? So if you put the values here and solve, ultimately the value of Biot number is going to come, which is way higher than 0.1, right? A lot times higher than 0.1, almost 200 times more than 0.1. So definitely if you were looking forward to apply lumped analysis on the basis of Biot number, you will not do that, right? In this question you will now explore other possibilities, maybe calculate Fourier number and all. But let me tell you that if you went into that direction, you are going to waste your time and you are going to get a wrong answer. Why? Why, sir? Biot number is more than 0.1. Then obviously we will explore other options. We might calculate Fourier number and all. But I am telling you that in this case, even if Biot number is more than 0.1, still we are going to apply the lumped analysis only. We will rather not look at the Biot number to calculate, to use the lumped analysis, and without even looking or calculating Biot number, we will directly apply the lumped analysis. Why? Because here, this question is different. How is it different? Because whenever we used to solve the questions of unsteady state conduction, we did not use to interfere with the body. If the body is there, gradually heating or cooling, it used to cool or heat at its own pace, and in the temperature distribution also in the body, we never used to interfere. But if you read the question carefully here, we are stirring it constantly, we are interfering it, and it is ensuring that temperature is uniform at all times. Temperature at different places is not changing. Uniform means what? With change of position, with change of location, temperature is not changing. That is what uniformity is, right? The basics that we covered in fluid mechanics, those basics obviously are going to be used in heat transfer. And that ensures that temperature is same throughout. This means it is acting like a lump. What is a lump? A lump is a body thermally where temperature gradients are negligible, are very small, or they even don't exist. That is a lump. And for those lump bodies, we can apply lumped analysis. In this case, if this body was cooling at its own pace, if this man was not in a hurry, this person who is stirring it, he definitely is in a hurry. But if he was not in a hurry, and if he allowed this process to happen at its own pace without trying to disturb anything, then definitely this is not a lump and you cannot apply lumped analysis. But this person stirring it continuously, making the heat exchange easier by stirring, by mixing, made the temperature uniform, and essentially any temperature gradient between the body got vanished. That's what question has given you, right? And that is why even though if you applied Biot number, that would have given you a value higher than 0.1, still you will use lumped analysis. Are you getting the point? This number, this calculation is not having any relevance for this case, because in this case we are interfering with the heat transfer. If we were not interfering, then it was a separate issue. Then we would have gone and explored further steps. But here, since we are interfering, we have ensured, this person has ensured that it is a lump, it's lumped analysis case, and without even calculating Biot number, we are directly going to jump to lumped analysis calculation. This is the beauty of this question. This is the beauty of this concept, that you never have to read the question carelessly. Whatever word or language is given, always use basic concepts, keep your eyes and mind open. Question gave you a hint, many students miss such hints. And then obviously, solving a question wrong is something else. But wasting a time on a question is even worse. And this is one of those questions where students waste time. They keep on trying different things and they waste 5 minutes, 6 minutes on a question. And ultimately still they will not be able to get to the answer, because Biot number, Fourier number, all those calculations will not matter. So it not only takes away your time, which you could have used in other question in exam, but ultimately you will never get the right answer by that approach. So this is a dangerous question. If it comes in gate and you are not aware and you missed this statement here, if you missed this statement here, stir continuously this statement, it's a dangerous question, right? It can just set you back by 2, 3, 4 marks also. Why I am saying 2, 3, 4 marks? Because if it is consuming time of 7 minutes, 6 minutes to solve, definitely in that time you could have solved some more question, additional question. That's why this question can consume your 4 marks, 5 marks, right? Now, when we move on to solve this question using lumped analysis directly, so initially it was at a temperature of 3 degrees Celsius. It needs to go to a temperature of 38 degrees Celsius, and ambient temperature is 60 degrees Celsius, as I already explained you, right? Large hot water tub. And now this entire left hand side is sorted. We know all the values, right? And for the right hand side, we need to calculate this coefficient HA by rho Vc. So to find out the value of HA by rho Vc, let's not directly put the value here and try to do some calculations, try to do some simplifications here. So here area, as we already discussed, is the curved surface area plus the top and bottom area. So area is 2 pi RL plus 2 pi R square, correct? Divided by rho Vc, V is pi R square L. Now at this point of time there is a small mistake possible, that if generally whenever we take these cylinders, we have a habit of writing this as height h, right? But in the questions of heat transfer, that can cause some silly mistake by some students, not all. That while putting the values, they may confuse between coefficient of convection and height, right? Especially there, if you just look at this value, and you opened your virtual calculator and you started calculation, correct? So here I am writing everything, showing every step. So clearly I will, if I write it as h, my mind and eyes will check it. But suppose you are on your screen and you have opened your virtual calculator and now you are doing the calculations. So h, quite possible that you will put height here, 7 centimeter, 0.07 here in the calculation. And then obviously you will do the area calculation. There you will obviously consider again the height. So this h will get miscalculated as a height in place of coefficient of convection. It's a possible mistake. I have seen some students do such mistakes. That is why please make sure that in such cases of heat transfer, convection, or wherever you are going to have these coefficients, please make sure that height is written as a different number. Preferably you can use L to represent height, right? Length. So here if you put the values and simplify, what we are going to have, from the numerator 2 pi r will come out as common, 2 pi r, right? Here also it will come out as common, here also it's square, so 2 pi r will come out as common, only r will be left. And 2 pi and pi will cancel, r and 1 of the r will cancel. So you will have 2h L plus r divided by rho r L c, Correct or not? Now you need to put all the values. H value, I already told you what it is. Length or height, known to us. Radius, known to us. Density, known to us. And specific heat, known to us. Right? All these things, density, specific heat, length, height, everything is given to us in the question. So you need to just put the values. Make sure to convert the units into appropriate values. Basically, the length will be calculated to meters. Rest all are fine. Correct? And in case of specific heat, it is in kilojoule. Right? So you need to multiply that with 1000. These are the two changes that you need to do. Right? C value to joule and lengths to meter. Okay? Now, putting all the values, this is the value of HA by rho VC that you will get, and now you need to put it back here. Left hand side values are known to us. T is the only unknown, right? So if you put all the values, you simplify, then you take the log, and after taking the log, this value will be for left hand side and this exponent will come here, right? And then you just simplify it. The value of time will come out to be in second. Again, a point to note, right? The value and the calculation that you will do here, those calculations will come out in second. If you look at any unit, let me highlight all the units. Centimeter is 1 unit, right? Then degree Celsius, then this, then this, then this. Any of these units, do they have any unit of time directly visible? No. So some of you may get confused and directly whatever answer you get, you will put here. But what is watt? What is joule per second? Right or not? So this has second included in this. So the calculation that you are going to do here, the answer you will get in second only. That you need to convert to minute. And then you are going to get 5.8 minutes as the answer, because question was asking you the time taken to move from 3 to 38 in minutes. So from this question, a very easy question, but a question with different types of conceptual as well as silly mistakes. So I hope next time when you are going to solve a question from lumped analysis, you will pause for 1 second and ensure that you have read the question correctly and you are not just assuming anything and you are just directly going to calculate Biot number. Please spend time with the question. Please respect the question. Read things carefully. Try to figure out what it is trying to say. After that, it makes sense to, start solving the question. All the best.